This video is on the applications of trigonometry or rather heights and distances. So part 3, and this particular topic, applications of trigonometry, I have divided it into two videos. The first video is relatively simpler questions, and the next video will be a slightly higher level questions. So let's get started. Applications of trigonometry in heights and distances are all about forming the right angled triangle and with the help of the question given. So here I am suppose that this is a pole and you are standing over here on the ground. So when you are observing anything, normally you would be observing like this. That means that is this line of sight, your line of sight is going to be parallel to the ground below. But if you want to observe the top of the pole, your line of sight from this is going to shift to this. That means there is an angle that is formed, and this angle is called the angle of elevation. In this one, you will observe that this is a right angle over here. So there is a right angle over here between the pole and the ground, and your angle is formed, that this angle of elevation between the original line of sight and the new line of sight. In the same way, let us understand, suppose you are standing on the top of a lighthouse and there is a ship below. So when you are standing on the top of the lighthouse, your normal line of sight would have been this straight, and you observe that this is parallel to the ground over here, ground or the sea. So when you want to observe the ship, your line of sight from what was parallel to the sea will now shift downwards to this situation, and therefore there is a depression over here, and this depression, this theta, is called the angle of depression. That is, your angle of depression is the angle between the original line of sight and the new line of sight. Again, over here, if you observe, there is a right angle triangle over here. Right angle triangle formed where your lighthouse is the vertical, your sea is the horizontal, and your line of sight becomes the hypotenuse. And this angle of depression over here is also becoming the same as the angle of depression over here, because this line, you observe, this line of sight, original line of sight, is parallel to the parallel to the horizontal, and therefore this angle and this angle are going to become alternate interior angles, and therefore your depression can be now shifted to this angle, and you can simply look at this triangle. Now let's start with the first question that I've taken. A man observes the angle of elevation of the top of a building to be 30 degrees. There is a building, and there is a ground on which the man is standing over here. Suppose that the man is standing over here and he is observing the top of the building to be equal to 30 degrees. This is equal to 30 degrees. This is the top. He walks towards it in a horizontal line through its base. That means he walks towards it, towards the building like this in a horizontal direction. So suppose that he walks till here. So now at this point he is walking till here, and that is given to, he is walking 60 meters, on covering 60 meters. Now the angle of elevation changes to 30 degrees. Now the angle of elevation changes to 30 degrees. Sorry, 60 degrees. So this is going to be 60 degrees. So he's asking, find the height of the building. Find the height of the building. You observe that there are two right angle triangles. One is this right angle triangle, and the other is this right angle triangle. And in both of them, the building is the common part. The vertical is common. Let's go to the next one. Now let's look at the neatly done figure. So AB is the building. The man is standing. A man is standing at the point D, and he is walking towards the building. So he has walked 60 meters, on covering 60 meters up to the point C. So here the angle of elevation from D is going to be 30 degrees, and the angle of elevation after covering a certain distance is equal to 60 degrees. There are two right angle triangles over here, triangle ABC and triangle ABD. Now you children, sometimes you get confused between whether you should put 30 degrees over here or 60 degrees over here. Please remember that as you are going closer to a particular building, your eyesight, how much you raise your eyes in order to look at the top of the building is going to increase. That means your angle of elevation is going to increase. Okay, now that we have understood the figure part, let us get to the calculation. That is, in triangle ABD, tan 30 is equal to opposite side, that is AB divided by BD. So here you are getting 1 by root 3 is equal to AB by BD, and AB is equal to BD by root 3. Here in triangle ABC, tan 60 is equal to AB by BC. That means root 3 is equal to AB by BC. Therefore, root 3 into BC is equal to AB. In most of these questions, you will always find something that is common, and we will come to whatever that is, AB is equal to AB is equal to, and we compare the two parts. So over here, from 1 and 2, we get AB is equal to BD by root 3 and AB is equal to root 3 BC implies BD by root 3 is equal to root 3 into BC. So the root 3 comes over here. This is BD is equal to 3 times BC. But your BD is equal to 60 plus BC. So 60 meters plus BC. So BC is equal to 30 meters. I substitute this 30 over here. I will get BC is equal to root 3 into 30. That is 1.732 into 30. That means I'll get 51.960 meters. But my question is, find the height of the building correct to the nearest meter. So I am to convert this 0.96, I round it off and I get AB is approximately equal to 52 meters. So the next question that I have taken is, two pillars of equal height stand on either side of a roadway which is 150 meters wide. So there is a road over here which is 150 meters wide. And there are two pillars which are on either side. So there is, and they are both equal. So if this is one pillar, this is the other pillar, and you observe that both of them are of equal length. At a point on the roadway between the pillars, the elevation of the top of the pillars, so at a point somewhere in between over here, at a point in between, the top from here and top from here is equal to the angle of elevations of the top from a point P is 60 degrees and 30 degrees. Find the height. Again, you will get confused between whether the 60 degrees should come here or 60 degrees should come here. As I told you in the previous question, the closer you are to a particular building, your angle of elevation is going to be much more, and this is going to be equal to 30 degrees. So let's go to the proper figure. So here AB and CD are two pillars. AB and CD are the two pillars, and we have of equal height. So AB and CD are two pillars of equal height, and there is a point P in between the road BD, which is equal to from where the angle of elevation is 60 degrees and 30 degrees. So we are given that AB is equal to CD, and also we are given that BD is equal to 150 meters. I am saying, suppose PD is equal to X, that implies my BP is equal to 150 minus X. Again, I told you we have to look for right angle triangle. So this is one right angle triangle and this is the other right angle triangle. So in triangle ABP, tan 30 is equal to AB divided by BP. That means AB divided by 150 minus X. Or you get AB is equal to, here tan 30 is equal to 1 by root 3. This implies 1 by root 3 is equal to AB upon 150 minus x. Therefore, your AB is equal to 150 minus x divided by root 3. Then in triangle PCD, tan 60 is equal to opposite side CD upon PD, but PD is equal to x. That means your CD is equal to root 3x. Now you already know that the pillars are of equal height. That means from 1 and 2 we get 150 minus x is equal to root 3x, and therefore x, when I simplify, x is equal to 150 divided by 4, that is 37.50 meters. That means the point P is at a distance of 37.50 meters from one of the pillars, And because AB is equal to CD, I will get is equal to root 3 into x, that is root 3 into 37.50, that is 64.95 meters. Therefore, the height of the building is 64.95 meters. So you find the height of the pillar and the position of the point. So you have found the position of the point and the height of the pillars. So the third question, the angles of depression of two ships A and B as observed from the top of a lighthouse 60 meters high are 60 degrees and 45 degrees respectively. If the two ships are on opposite sides of the lighthouse, find the distance between the two ships. So let's draw the figure. So there is a lighthouse over here, and this is the sea. On the sea, there is a point which is A, and there is a point which is suppose B. So you are saying A and B are observed from the top of the lighthouse, from the top of the lighthouse. So from here, the normal eyesight would have been like this. So this would be 60 degrees. So alternate interior angles, because these two lines are parallel to each other, and this side will be, so this would have been the normal eyesight, but it has come down. So this is 45 degrees. So this is 45 degrees. And then that is, you are saying this is your lighthouse. This is one ship. This is the other ship. A is at a distance of at an angle of 60 degrees, and B is at an angle of 45 degrees. Let's come to the correct neat figure. So over here, I have shown the point A. There are two ships, point A and point B. At point A, which is at an angle of depression of 60 degrees. Therefore, the angle of depression over here, this angle now becomes 60 degrees. PQ is the building which is 60 meters high, and the second ship is at an angle of depression of 45 degrees. Therefore, this angle also becomes 45 degrees. And we want to find out the distance between the two ships, that is A and B. We have again two right angle triangles over here. This is one right angle triangle. This is the other right angle triangle. So in triangle BPQ, I'm getting tan 45 is equal to PQ upon BQ. So tan 45 is equal to 1. So I'm getting PQ upon BQ, that is PQ is equal to BQ. So this is 60 meters, that is BQ. Now the beauty about 45 degrees is that whenever you see 45 degrees, you know that this opposite side and the adjacent side are going to be equal, because tan 45 is equal to 1. Let's go to the next triangle. In the next triangle, that is triangle PQA, tan of 60 is equal to opposite side upon the adjacent side, that is 60 upon QA. So root 3 is equal to 60 upon AQ, that is AQ is equal to 60 by root 3. When you have an irrational number in the denominator, you will not divide by 1.732. What you should do is you should rationalize the denominator, that is divide by root 3 by root 3. So this denominator will become 3 when 60 divided by 3 will be 20 into root 3, that is 20 into 1.732. I am getting AQ length to be equal to 34.64. Already we found out BQ to be equal to 60 meters, and this is 34.64, and therefore distance between the two ships distance between the two ships AQ plus BQ is equal to 60 plus 34.64, which is equal to 94.64. But he has asked you what is the answer up to the nearest whole number. That means that is equal to 95 meters. If you leave it over here, you will lose half mark. So please write down correctly that is equal to 95 meters.